All right, so question 7.76. Let's start out with the first one. So we've got a secondary alkyl halide. We've got SH minus, which is a sulfhydryl ion, so Na plus and sulfhydryl. So remember that sulfhydryl is considered a weak base, but it's a strong nucleophile. So we'll put here weak base, strong nucleophile. So the only mechanism that's going to occur here is an SN2 and nothing else. And remember, that's going to occur via inversion of configuration. We get our nucleophilic attack and loss of leaving group. And so now you've made a thiol. So we'll put that here, thiol. So we get inversion of configuration. The next one, we have a primary alkyl halide. So this is primary. We have DBU, which is a strong base, but it's a very weak nucleophile. So there's going to be no SN2. It's only going to be E2 in this case. And the only beta proton we have, if this is our alpha proton, the only beta proton is this one here. And so the DBU, I'll just put a lone pair of electrons on the DBU, and we'll go over the structure of DBU next class. It's just going to remove the proton, make a double bond, and we lose the bromine as a bromide. And so the only thing we get is 1-butene in this case. The next one, we have hydroxide, and we have a tertiary alkyl halide. Hydroxide is a strong base, and it's a strong nucleophile. And so if we have a tertiary alkyl halide with a strong base, strong nucleophile, the only thing that we're going to get here is going to be, if it's tertiary with a strong base, and we also have water in here, which is, I'm reading the wrong problem. Okay, I'm looking at this problem when I'm supposed to be looking at this problem. Anyhow, let's get back to it. So we have a tertiary alkyl halide. We have hydroxide, which is a strong base, strong nucleophile. So the only mechanism that's going to occur here is E2. And we have two possible places where we can deprotonate here. We have these protons here in red, and then we have the beta protons in blue. If we rip off the blue proton, we get the Zaitsev product, and this would be the major product. And if we pull off the red proton, we get the Hofmann product, which would be the minor product. So minor product there. The next one was the one I was reading before. So we have water, which is a weak base and weak nucleophile. And we have a tertiary substrate. So the only thing that can occur here is SN1 and E1. And so the SN1 product is going to be the product of substitution. So we're going to substitute the bromine for the hydroxyl. And then for elimination, we're going to get both the Zaitsev and the Hofmann. So we're going to get both of these. But of course, the Zaitsev is going to be the major product. So we'll put this plus this, and the Hofmann will be the minor product. So somebody said, is sodium hydroxide only a strong base and strong nucleophile when it's in water? No, in any solvent, it would be considered a strong base and strong nucleophile. Yep. All right, the next one, we have a secondary alkyl halide. And we have T-butoxide, which is a strong base, but it's a terrible nucleophile because it's so hindered. So we'll put weak or poor nucleophile. So that means the only thing that's going to happen here is elimination. And it's only going to pull off the less hindered proton, right? I guess it could pull off a little bit of the blue proton, but the major one it's going to pull off is the unhindered proton, the one in red, which would give us this as our major product. So I would say that this is the major. I didn't look at the solutions manual, but it might form a little bit of this. But maybe not, since that proton is so hindered. And then an F, we have a tertiary alkyl halide, and we have a strong base, strong nucleophile. And so the only thing that we're going to get here is, so if we have a tertiary, we have a strong base, strong nucleophile, the only mechanism that's going to occur here is E2. And so there's two products that we could form here. we could rip off the blue proton, which is going to be the major product because we have an unhindered base. So this is the Zaitsev product. That's going to be major. And then you could also pull off these protons in red, and that would give you the Hofmann product, which is going to be the minor product. Minor product. So there you go. So I didn't write down here that this is going to be E2, and then this one is SN1 and E1. And yeah, the rest of the mechanisms I wrote down. There's one more, which is G, and we'll save that for class on Monday.